I got rid of Brooke and brought in Steven.
We ditched her. Maxim's sitting in where I thought she would be.
She was sitting where you are yesterday.
Yeah. Gina says thank you. You're welcome for ditching her.
Yeah. We won't tell her you said that, Gina. Just kidding.
She was wanting a link to the survey.
Oh.
Somebody else gave it to her. For the, what is this called?
This is called Gateway Mission Lockbox.
Okay, the lockbox activity. Your title was too long. It's a great title though. But it's for this one, it's with Brooke when we sat down and designed it and put that together. As you noticed, there were with the different activities, it kind of hit all the grade levels. And so what she basically did was designed as a group just the one activity, one lockbox activity. And so there's not new lockbox activities for each of the grade levels. She incorporated standards for each of the levels in it instead of doing a brand new one.
Right.
Just to give you a heads up.
So this will be the same presentation. I mean, not the same, like we'll probably say different words, but it'll be going over the same lockbox that we went over yesterday. So you're welcome to stay.
If you weren't there yesterday and you want to hear it from like Brooke, you'll have to wait till tomorrow.
Right. Brooke will be back tomorrow. We'll all three be here tomorrow.
Yeah, I'm not going to stay here with you two.
You're not.
No, I'm going over there.
I'm going to jump in and just remind everyone that there's my email. If you want CRUs, please send me an email for being in the session. We give you 4 CRUs, 1 hour for being here today, and then 3 hours for doing the lessons. So just send me an email with the last 4 of your SOC. And yes, you have to do this every hour that you're here. So if you're here all 4 hours today, you're sending me 4 emails. There, I've done my, and Sarah, I am recording.
Thank you, Bill. Awesome.
Did you get the links to the others, Bill?
The links to the others.
For yesterday's recordings?
They have not come up yet.
Hey, when you set that up, sorry for the background work, gang. When you set that up, did you set that up to record in the cloud or locally?
I thought it was locally, and that's what I originally said.
Okay, if it's locally, it's usually just a pop up behind it about a few minutes after. So you probably already have those on your machine.
Oh, okay.
Locally, you won't get an email.
Okay, Shauna, yes, there is a link. It's in, right now we have the link under Tuesday in the Purdue University College of Science K-12 link that Bill sent. And Bill, it's the same link from Tuesday. This will be the same link if you want to go ahead and copy it there, but I'll copy and put it in the chat as well.
Okay, I'll move it over to today's link as well.
Perfect.
Is that this presentation? Yeah, that's it.
Yes, that's it. Okay, I'm going to go ahead and share my screen. And thanks everybody for your patience.
Hey, it's working.
All right. And we will get started here. So welcome. We're going to talk about a virtual lockbox activity today. We'll talk at the end about transforming this into a paper and pencil lockbox. I know some of the participants received materials from us, and a couple of the things you received was an actual box that you can place a lock on and a lock. I think they were directional locks, if I'm not mistaken. So this is certainly an option to turn this into a paper and pencil lockbox, but we're going to go through the virtual version first. And what you have right now is a link you'll be able to get into this. It's going to automatically copy. And this is going to force a copy of this page into your Google Drive. And that's just logistically, that way it just gets there for you. And then you can edit this and make it however you want it to be. We have our background story, but before we get into that, I just want to start with that when we do these lock boxes, it's great to have an activity that's going to keep the kids busy and sometimes we just kind of need that for our own planning purposes and to kind of reward them and give them something fun and something to look forward to. But we also always want to think about that, what are they actually getting out of this? And that we designed, Brooke and Stephen and I designed this lockbox with the intention, we started thinking about what do we want the students to know when they're totally done with the activity, so that we're designing it with a purpose, that we have goals in mind, those educational goals in mind. And we're not just designing it just as we're just going to use this as a fun activity. It is fun, but we also want to make sure that we're covering standards that we might already be covering in other classes. We really like this because we're covering some of the science things that we're already talking about in other sessions. We're also covering standards from 6th, 7th, and 8th grades. So all 3 of the grades are all, wrapped up in this one lockbox activity. There are definitely lots of ways you can modify some of these. And certainly there are 3 total gates that you'll see. Those could all be standalone challenges as well. So you could definitely separate those out. So getting into our background story, we have this secret location somewhere around Cairo, but you could change that to any other location really in the world. We stuck with the Northern Hemisphere because that's the constellations that we chose, but we will show you when we talk about the first activity, how you could really modify this to be any location in the world, even your own location if you'd like.
Cairo, Northern Hemisphere?
Mm-hmm. Yeah, Egypt.
I don't know. It was just on I just watched a movie that had it in it. And so
yeah.
That's why I picked
That's
it.
why you picked
I don't know.
There you go. There's the backstory. This is how a lot of our things happen, right? Stephen watches a movie and then we do an activity based on what he saw. And then anyways, a paleontologist and anthropologist discovered an artifact that predates human civilization, and you have been assigned to this top secret government project, and everything contained in these files is highly classified. Physicists have discovered that this artifact is a series of 3 gates that will transport people and items beyond our Milky Way galaxy. Your team is tasked with finding a planet within these other galaxies that is suitable for both research and human survival. So that's the ultimate goal, is that we're trying to select a planet from one of these galaxies that's going to both support our research and let us live there, because we probably can't go back and forth, I guess, in this scenario between Earth and wherever we choose. Here are our chart. We're going to see 3 columns here, and these teacher links are all, again, they're all going to force a copy for you, and you can edit these and make them whatever you want them to be. This hopefully just gives you a starting point to, it's kind of the structure is set up there for you. Under the student links, everything you're going to need is in this very first link right here, this gateway mission. It says a Google form. It's a student example. Yesterday, I had it set on the original Google form to only accept, or I limited it to 1 response. So I went to get into it today and it was like, you've already completed this form. And I was angry at my computer, but then I went back and changed it. So I removed that limit to only 1 response. And it works now. So I've pulled that up. But definitely when you want to share this, the first thing you're going to want to do, just in case you're unfamiliar with Google Forms or how they work, is you're going to force this one under teacher links, this Google Form copy. That's going to force the editable form into your drive. You go ahead and make it the way you want it. If you want to change the location, change any part of the story, get rid of anything, you go ahead and do that. And then you're going to share that link with your students. That's how they'll, and that way, and then also if you want to set up the spreadsheet, so that way when you share this link with your students, their responses all go into your drive in your spreadsheet connected to this Google form. And if you have any further questions about setting up Google Forms or how to collect student responses, please feel free to send us an email and let us know. I'm happy to walk you through all that. But today, just to illustrate this, we're going to work on, I've just given you a sample link that will connect to my Google Drive, my form on Google Drive, just so you can see what's going on. Each of the puzzles, you'll be directed to each of the puzzles within the Google form. So they really only need the link to this one form once you have it set up the way that you want it. But this way you can see what they're seeing with each of the Jamboards. We are using Google Jamboard, and we'll talk a little more about Jamboard as we're going through it. It's pretty fun. And I know we had a question yesterday, how familiar would students be? Do we need to do some Jamboards ahead of time? Is this going to confuse the students? And I'll just say that Brooke is really holding off on jumping on the Google bandwagon. Like she just doesn't, she gets really uncomfortable when we do, I can say this because she's not here. When we do Google Docs and Google Sheets and Google Slides and things, she's like, she likes her Microsoft and she likes her her Mac computer. And so she gets uncomfortable.
Old.
She's old.
But she's old. She's scared of technology.
She
Kids
is.
aren't.
She's always really hesitant. And so well, in the last couple of weeks, this was the first time she had seen Jamboard. And she was saying yesterday how she's like, this really was very intuitive. I figured it out. And she is not one that's real comfortable with, especially with the Google suite, Google products and things. She's just kind of been hesitant about that. So it has her seal of approval. And I don't know what that means, but I think the students definitely are going to feel comfortable with these. All right. I'm going to switch over here. I just clicked on that student example link that you see, and it's going to take you to the puzzle. And like I said, the kids, when you assign this to your students, they're going to get everything they need, all the clues, all the information from this link, the way it's set up now. So the first thing it's going to do, it's going to collect their email. The idea behind that is that when you have the Google form set up in your own drive and you've set up the spreadsheet to collect their responses, this is how you get that identification for them. And I know a lot of you are like, yeah, I know all this, but just in case anybody is not familiar with how the Google products work. So I'll go ahead and put my email in. And then we have this nice picture. So here's our artifact that was discovered in wherever location, Cairo right now. Cairo. And here is gate 1. So we have a series of 3 gates. And the very first gate says we have the same backstory, but then we're going to find clues and instructions to pass through gate 1 here. And when we click on this, it's going to force a copy of this. So you're going to get this kind of a scary screen. I was a little alarmed the first time I saw this about a year ago. I thought, what is happening? But this is just telling you you're making a copy of that original document and that it's putting it right into your Google Drive. So yes, I'm going to go ahead and make a copy.
Well, that's making, I like the Molly, right? Right on. That's one thing that we didn't mention is expectations, because you can do a lot. And it's a live share once again, and the kids are a little more used to working collaboratively, virtually live than they used to be now. And so expectations and rules of that definitely need to be shared with students prior to something like that, because Bill would get on there and draw inappropriate things. We need to prevent him from doing that. I would never do that. But it would offend Sarah, so we don't want to do that.
Yeah.
So yeah, definitely before you anything like this, but even Google Docs, you have to do that. Right. And remind students that, yes, it saves history automatically, and I know what you did, and I can look it up. So let's just avoid it to begin with and not make poor choices.
I know that my own kids, I have, my son is in high school now, but my daughter is going through middle school now, and they both are convinced that everybody within the IT department at the school, that they can see everything that's ever been typed on their machine. I don't think they really can, but I let them believe this, right? Just so they know, like, they are just convinced that, anything they can do, it's going to be seen. So hopefully that scares enough the kids. But
she says Jamboard doesn't have save history.
Doesn't have a save history. Okay. I wasn't for sure about that. I do know that this has the option that kids can get on the same Jamboard. Because I only know that because the 3 of us were all on the same Jamboard. We could see each other, especially with this one, that we're plotting these points to get the shapes of some constellations. So we could have, up to, there's 6 constellations. You could have 6 kids all on there plotting. And we really like this as opposed to like a Desmos or a GeoGebra or an app like that, because this is actually, you're not just typing the coordinates in. The kids are actually, just like they're using paper and pencil with grid paper, they are reading these coordinates and they're going through and they're plotting. Over here, we see this really cool pen tool. You can click on that and you can choose, your pen, your marker, your highlighter, and then you go through and you say, okay, -11, -1. I'll do one that I don't have to count too much. 0, 10. All right. So here's 0. I go up 10. I don't know. I'm just kind of estimating because I'm nervous in front of the camera. That's why. But yeah. What?
You can't just estimate. You got to do it right if you're going to do it. That's offensive.
1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, hey, I'm pretty good here. 0, 10. I'm graphing. Now I've lost track. Okay, this is Constellation 2 that I'm graphing. Oh, wow,
What?
someone
Wait
had
a
over
minute.
30 kids on a jam. Here, you look at the comments because I can't see them. What
Well,
does that
I'm
one say?
looking at the comments, but you just keep talking about them.
Well,
She said she had 30 kids on the same on the same Jamboard. Oh, and you do the different slides, have different ones on different slides.
oh, that's perfect. Yeah, that works really good. But they're plotting these and they're going to get these shapes. And then let's say we get a couple of these plotted. I got 0, 10. I'll have 10, 0. Well, anyways, we get a few of these dots just for illustrative purposes here. I'll put these down. And then we say on the side, we have this this pen tool. You can connect and hold. If you press and hold shift and then click and drag from one point to the next and then let go, and it's going to give you this nice straight line. So you shift first and then you press where you want to start the line and you hold and you drag to the other part and then you let go of everything and you get these lines. So this, I'm talking and trying to plot at the same time, so I'm not being very careful with this, but you know, your kids are going to come up with these shapes, they're going to plot these, they're going to get these constellations. And then what they need to do is slides 2 and 3 show these maps of the Northern Hemisphere sky at different times of the year. We selected constellations from both a November sky and a summer sky. So we have a mix of these constellations all on one. And what we'd want to do is we'd want to compare the shapes that we have with the next couple of slides. Here is the summer sky. So we're saying, okay, well, which ones do these look like? And here is our November sky. You could definitely choose constellations that are all within one sky. Maybe
You're
November,
gonna show them that link?
maybe summer.
We didn't think about until afterwards that. I mean,
That's right.
Brooke pulled this part. I mean, you know, we sat down, divided up what we're doing, and then afterwards, what we thought of is using the. Where is the link?
It's in the teach. So in the teacher link, I'm going to pull that one up, which is why I'm back here on the original. That was a student link. This is the teacher key.
What about the website?
Yeah, it's on the teacher key.
Oh, it's on the key. Okay.
Yeah.
But what I would do if we're going to do this again is go to this website that I'm like really trying to get her to go to, but she's not doing. I don't know why. She has to be that way.
All right, here we go. The Sky and Telescope is the site.
I thought you were going to the website.
Oh, we can go to the website.
Well, I see
well,
that
it's
the
here,
time.
but this just okay.
Oh man, you're so difficult. Why do you have to be that way?
Oh, I bet everybody wishes they were right here. All right, here we go. We're going to copy.
skyandtelescope.org website. What I like about that is you can give the kids, say, you know, at this location and this date. And so that gets them, they go here to this, they can put the location, they can put the date, and it'll show them what's in that sky.
Mm-hmm.
And so you could pick constellations that's going to be at a certain place and certain time that'll be visible. And I like that. That's terrible.
Well, it's a daytime right now, July 21st at this time. But let's choose.
You just didn't hit submit.
Oh.
There's still stars, you just can't see them. Maybe I lied. It'd be the first time in my life I was wrong. But
oh, here we go. All right.
But so you can pick ones, and what I like about this is they start getting the understanding that we can see different constellations at different times, and so that starts building the foundations for them to understand the Earth's orbit, or
Earth's orbit.
We'll use your words; they're so much better. So we'll understand that they'll start building foundations to understand that.
Right.
So that's why, that's one reason I really like this particular one. And I know we do other things sometimes with constellations. It's how many people have done like the can lids and stuff, or even a paper plate, and they had them draw it and then poke it through and then put those up on the window. Then you can see those stars coming through. We used to do that with black paper and stuff. And so have them just draw it and then poke with their pencil the holes and you have the lines on the paper,
Mhm.
but then it's when you put it on the window, it shines through, you can see the stars.
Now that we've made this and we're reflecting now that it's already made, we're both thinking, oh yeah, we definitely should have chosen a place and picked constellations off of this screen. And that way they're just looking at one place. When Brooke had chosen these constellations, and I understand why she was thinking too, you know, choosing a few from different times, she had her son, who was also a middle schooler, go through and complete it. He was able to identify the constellations based on what we've included here with the student Jamboard. So he was able to plot them and go through, and so it's doable for middle schoolers.
Oh, it's fine. I just think it would
Yeah.
add to the story.
Definitely.
I just think it would add to the story and let us be a little more creative with our
Absolutely.
story.
Yeah,
the
I think
beginning
that'd be
story.
fun.
And so that's the only reason I think it would be even better like that.
Two other things related to this, and I just remember from our presentation yesterday that this can also be really cool, especially thinking about students and where they're located regionally. There are students, and especially I've known some, you know, maybe they grew up in a larger city, maybe Chicago, like around us, it would be Chicago or Indianapolis, or sometimes even Lafayette right here, that they don't always get a chance to see stars. There's too much light pollution and smog and different things that they never actually see the stars. And so it's kind of powerful to be able to show them, you know, if you could get rid of all that light pollution, if you could go to a really dark place, you know, today, this is what you would see looking up at the night sky in different locations. Another point, and I'll just go back to our screens. All right. I'm just trying to navigate so I can get to my tabs. It's a little awkward. If I go to the, you can see the plotted constellations that we have. And again, this is the teacher key that I'm getting from that original, that Gateway Mission Master, Lockbox Master. That you can see these plotted constellations. This is what the students are plotting, and this is then what they would need to come up with the names for to advance on, and we'll get to that here in a minute. Yesterday, after we had went through the activity, Brooke was reflecting on doing reverse constellations. So giving the students some constellations, and then having them come up with the points that they would need to be able to plot them correctly on grid paper. So here where we've given you coordinates and then they're plotting constellations, try giving the students constellations and have them plot those grid points. And you could easily turn that into a different kind of lockbox challenge, maybe using like all X coordinates from this will give you your code for the next box or something. That's just like a twist that you could do with that. And I really like that idea of reverse constellations, that you're using the shape and going to coordinates from there, and maybe even trading them with other students. And I like how it's incorporating, you know, the constellations that we're learning about anyways, but then like trading with each other to see, can I graph what they gave me? And if not, you know, where did I make mistakes or whatever? So it's kind of getting them to think about the coordinate plane both ways, you know, from plotting and then also reverse plotting. So anyway, moving forward, we have our names of the constellations, and I have them listed here. I also have them listed on slide 1. By the way, when I was doing this, if you're not familiar with Jamboard, this is super cool. There's this little arrow down under this tile here, and it shows you all of the slides, and you can reorder them. So you can click on them and reorder them, which I thought that was really a fancy thing. So just in case you didn't know that, it's just a little tip here. But they're going to get to the word search, and the word search, the students, of course, have a blank word search. And they can use this pen, this highlighter, and they go through, and there's all kinds of names of constellations. They are looking for the constellations that they graphed on the grid. And that is going to give us this nice code here. That's what they need to enter in to the Google form. So they're using all those slides, they're getting this code, and we go back to the form, and now they're going to go ahead and enter that in. So 1741. This brings us to gate 2, and you know, congratulations, you got there. Now we're changing topics. So we're switching from constellations. Now we're moving on to geologic timescale, which is leading into Stephen's session after our lunch today. We are going to be talking. This kind of matches nicely with the content that Stephen will be covering. I forget what time. 1 o'clock
We'll
Eastern.
We'll be here. We'll talk. We'll ramble.
That's right. I'm going to move this so we can get rid of that and then open up. Here's our next Jamboard. Oh, how do we create, Stephen, how did you create your word search?
Oh, the word search. I pulled up a Google Sheets. Thank you.
Mhm.
Google Sheets. You could do it in Excel if you wanted to, but I did it on Google Sheets. And go to where the numbers are, please. And so I always start because I've done a number of these. I enjoy doing them, maybe too much. And so the first thing I put in, all I do is make the cell sizes so they're squarish, and then I play with the whatever words I have to put in.
Mhm.
And that's where we had to put Libra in twice. And we say instructions, some will be used more than once because I needed more to make that 4. And so we just figured out I just manipulate them and put them where they want. And then I usually flood it with a bunch of other stuff. I'll have a couple of misspelled ones in there just because I'm mean. And then I'll have like half words in there, then a bunch of other words. We have like a bunch of constellations in there. If you look carefully, you see like Stephen is cool, Sarah's not, and things like that. It might be in there. So it's all of the pretty diversity. But do
Say no to IU. That's one of those.
actually it says IU sucks.
No, we got rid of that one.
No,
right?
I left it in.
Oh my gosh. You did. Thought we were supposed to. I know.
No, you told me to get rid of it.
I can see Andy's face right now.
You told me to get rid of it.
Inappropriate. I know.
Yeah, it's like a spreadsheet. Yes, it's like a spreadsheet. It's like Excel. Google Sheets is basically an online form of Excel. Yeah, Sarah told me to get rid of that one. I just forgot to. Oh, and
so yes, we did a snip. We
that's
used
just a
snipping tool, which is you can kind of see.
Can you,
you can see
hit your
down at the
snipping
bottom.
tool.
Yeah, if I hit snipping tool down here
For the presentation,
Mhm.
just use that snipping tool.
and I go to new, and it lets me, as this cursor here, I can highlight anything I want. And
Highlight
then
Andy.
Andy, there we
Get
go.
Andy in there.
Andy, you're getting on this.
He's gonna be famous.
All right, so there's our picture, and then I name it and save it to my. I usually just save it to my desktop because
I don't. I never save it to my desktop. Don't put a bunch of stuff on your.
You know what? That's just fine. It's just super easy to do that.
Wrong. Just copy it. Just hit copy and paste it in your doc.
Copy and paste
don't put a bunch. Don't clutter your desktop. It's wrong.
But then you can go to this on Jamboard. I set it as a background because I don't want the students accidentally deleting it or moving it around or doing different things. So when you go to set background, it's automatically on the default, which is blank. But then this right here is an image. You can select an image, and then I went ahead and selected that from my desktop from where it was mapped. And then it centers it on the Jamboard. So that way it's just a nice clean copy that the kids can highlight on, they can color on, they can let's say I'm crazy and I can't find words, and then you can clear it out. Oops, I would do that. Okay.
Well, you hit clear it out.
I didn't know it cleared out the Post-it notes. Good to know. I'll just use my eraser tool.
Copy still.
Yeah. Anyway, yeah, there we go. So it just makes it nice that it's set as a background, and then the kids, it's just like having a sheet of paper in front of them. We did the same thing with the grid paper back on slide 1. So that way it was an empty grid sheet. We just had to make sure it had the right number of cells so they could graph the coordinates that we gave them. And then this is as close as what I found to graphing paper and pencil, but doing it online virtually that we could find. And Brooke, as our math person as well, she liked this the best, of having the kids actually going through and plotting the points rather than just, like we had said, putting the coordinates in and letting an app graph it for them. All right, so we're going to open up our geologic time scale at this point now. Yeah, it's going to have the students make a copy.
Those other lock boxes we did, where did we save those so we could share those with them? Do you remember?
It's on.
Okay, just something to think about.
Yeah, it's on our produce side.
Just to
we have it.
confuse you and slow you down.
So here's our second gateway. And like we said, geologic time scale. And for this one, if we look back at the Google form, the students have 2 puzzles in this one now, right? And so they're going to use this Jamboard for the clues that they need. The first slide is for the first question, and the second slide is for the second question. And for this one, we're talking about this second gateway is a literal gate that measures 4.6 meters and has these symbols that represent important events in the different eras of Earth's 4.6 billion years of geologic history. So what this means, what we need the students to read into, is that 1 meter is equivalent to 1 billion years. And we're looking down through these eras and we see the time in years. We're counting today as 0.0. And what we want to do is we want to find, my window is in the way here, the distance along the second gateway in centimeters to the symbol for the first land plants. So I look down, okay, here's 0, and my first land plants are here. Now, this is 440 million years, and these are really big numbers for this, and obviously, right, for the students. And it gets a little tricky sometimes, like in turn, okay, well, does million come before billion? What does this even mean? But if you notice, we haven't reached 1 billion yet. So we're not quite at 1 meter. We're at 440 million. So then we're thinking, well, so if 1 meter is 1 billion, then how many centimeters would 440 million be? And that's the question. That's what we want them to know. So hopefully you're giving you a chance to think about that. We would be at 44 centimeters then for this. So that's our first answer, and we'll go to that here in a minute and plug in 44. 44 centimeters, and then we look at our second puzzle, and we say, okay, imagine if the time it takes for the first land plants to appear continually repeats itself. So we've got 440 million years, and then another 440 million years, and then another 440 million years, like that chunk of time is repeating. How many of those chunks of time, of those 440 million years, would repeat until bacteria are first found? So we're going to need to flip back to slide 1 and find where that bacteria is first found. We know here was our first land plants. I keep going. I see bacteria first appear in this Precambrian era, at 3.5 billion years. So the question is, how many 440 millions in 3.5 billions? And we're thinking, if we think about this in terms of centimeters, we would have 350 centimeters would be our time for bacteria, right? 3.5 billion would translate into 350 centimeters. And we're going to divide that by our 44 centimeters. So 350 divided by 44. And we have this listed on the key. So again, if we go back to our original starting point, that lockbox master, where we have everything, teacher links, student links, the teacher key has these in it. So that way you've got it there. But anyways, we divide that out. And what we want to know when we go on here is we want to know how many times would it completely repeat itself? So when you divide that out, you end up with 7.95. And we think that the students do a lot with rounding. And I think if you're not reading carefully, you might think, oh, 7.95 is going to give us 8. So I'll go ahead and plug in my 44. I'll plug in my 8. And it looks like 44, it liked it, but it gives me this error message for the second one. It's asking, are you rounding? Well, yes, I rounded, but I'm not reading carefully. How many times would it completely repeat? Well, it didn't completely repeat 8 times. It only completely repeated 7 times. Almost 8, but not quite 8. So that's what I need. That's that little trick there that I need to move on. And I go ahead to next. And that's what I needed to go ahead here. And just to comment a little bit on that since we're here, we like this puzzle, and Brooke was really instrumental in including this because she liked the idea of a unit ratio. Basically what we're finding here is a unit ratio, that it's however many times to 1. So we're finding that it's 7 units to 1, or 7.95 to 1 really, but that it's 7 complete units for those land plants where they occur in that era, to 1 unit for the bacteria. And that's just good to have those kids visualize how much time that is. We will never live 440 million years. We'll never live 440 years. Like, we just won't. But we are thinking that you would go through 440 million years 7 complete times and then some before we get to bacteria.
Was that hint? When you say the hint, do you mean for in the Google form? Yeah, it was that the one.
Yeah,
I think.
Yes, the so I can go back because I can't figure
the rounding
out.
hint. Yeah, that if you put the wrong one in.
Mm-hmm. There we go. This is just where we were. And yes, it's
Put
listed
8 in there
here.
again. It showed
Sure.
that again, please.
Yeah.
Thank you. But yeah, and then it says, "Are you rounding?" But
Mhm.
that's all. That's all. I
That's
don't know
all
where
it
the
says.
camera is.
And then
That's all it says.
then they need to go back to that last sentence. How many times would it completely repeat itself? So the key there is that completely repeat. It only, did Google do that or did you? Oh, yes,
Set it
I
up.
set that up. So just, we can jump to that quickly and I'll show you where you can go in and do that on a Google form. If you go back to your teacher links, and this is going to open up the editable copy for the Gateway mission. And it's kind of a fun thing to look at. So I'll go ahead and make a copy of that. But it's a response validation. And yes, you can set this up on your Google form in a lot of different ways. But you'll notice that all of these I set up as a short answer text. So if I go to this one in particular and I click on it, I set it up as a short answer text. And then I went down here, there's these 3 dots. I made it a required question. And at these 3 dots, I went to response validation. And so when I click on response validation, I just clicked off of it. Click on response validation. I have some choices. And I know that in this case, I wanted a number, but you could also do it to where it's like a text response, and you could put whatever the text that it would have to contain, certain things in it, or they have other options for you. I just went with number. And then as far as number is concerned, you have a lot of choices here, greater than or equal to, less than. I just went to equal to because I wanted it to equal 7. And if they don't type in 7, I wanted them to have some kind of hint that would be like, oh yeah, so I think it was, did you round? Whatever.
Can you put multiple ones in here of those, or is it just a one? Can you only do one hint?
In this case, yeah, in this case, I can only do one hint. If you want it, I have done these before. There are different options with the way that you want your response displayed. So like if you wanted them to have a different feedback based on what they chose, you can always do like a multiple choice, for example. And if you do this for multiple choice, and let's say you have, how about 7 and then 8 and then
you can do the response verification
9.
for each one.
Yes. So what you can do for that is you can go to a section based on an answer, and then you can create sections past this. So if they get 7, they move on to the correct section and you can move on with it. But if they get 8, you could have a different section that they would go to that maybe would give them a different screen that would say like, okay, when we're rounding, remember to do this, or remember to look at complete. And then they have to click something and then it can take them back to this question. So you can include some loops in a Google form to add in that remediation if it's needed. So it's really cool. And we can do a lot more with Google Forms. If you're interested in that, just let us know and we can, talk to you on a more personal level about that. But if we go back to what we're doing. So, okay, I'll go ahead and put my 7 back in. We'll get to this last one, make sure I'm doing good on time. We get to our last gate, gate 3. And now we are at this holographic projection of a solar system. There's 3 different planets. And we want to know which of these each of these planets has 2 very distinct fauna, which Brooke was blown away by this. Or I guess she's never heard fauna before. Remember, she was kind of like, what is this? She's so math. She just doesn't want to cross over into science at all. It says one is very dark and absorbs a lot of energy. The other is very light and reflects a lot of energy. And what we're looking for is that ratio between light to dark, because if the ratio is too great, we're going to generate shear winds from convection currents. And that is tomorrow. We are doing air masses or air convection currents and things tomorrow in a session. But it'll be too great and it will tear apart research equipment. It will create this really harsh environment that we don't want to live in. So what they're going to have to do is calculate the ratio of light field to dark field air mass volumes for each of the planets, and then choose the planet that they think would be best. Oh, yay, Google Form tricks. Okay, I know, I love all these tricks, Google Form, Jamboard, all these. And I'll get too derailed if I start talking.
So we could do a whole session on that.
I know, we really could. But we'll go into this last instructional. So this is our last Jamboard that's taken the students. Also, I should just remark, I love that you can put these hot links into a Google Form to take students to places where they can do work, and then obviously they're already on the internet, so then they can go back to that other tab and go back to their Google form. I love that you can direct them to these places. I feel like that's really useful and helpful. Here we have 3 slides, and the students are given a diagonal of the field for both the light field and the dark field, and they're given a side for both the light field and the dark field. And what we're asking them to do now is to use their Pythagorean theorem, which they know how to do this, right? And that they're going to have to find that missing side. This is all that they have. They also have the height of the atmosphere. And what we want them to do is find the ratio of the air mass volumes between the light field and the dark field. Now, because we are running a little short on time, we're going to go ahead and just jump straight to this. Oh, yeah. So we're going to plug this in. We're going to find, use the Pythagorean theorem to find our missing side. And then we're going to, find the area of the field. We're just taking the side times the side. We get whatever that area is for the light field. We do the same thing here. We're going to find whatever that area is for the dark field. And we're doing the ratio between the light field to dark field. So the light field light field volume on top. First of all, sorry. We're going to take our calculated areas and multiply them by the atmosphere height, and that's going to give us our volume. So now we have our air mass volume. Then we're taking our light field air mass volume divided by our dark field air mass volume to get that ratio. So we will have a ratio for fields. These planet 1, planet 2 has different values. You'll notice a different atmosphere height here. Planet 3 also has different values. We're going to get a ratio for each of these. Now, I will say kind of in the planning part of this, and Brooke had highly suggested that we use Pythagorean triples. And so that just ensured that the values that we were giving the students wasn't going to be crazy with radical values. You definitely could do that. But we just looked at Pythagorean triples and just chose some that we thought looked nice and kind of looked similar.
So full disclosure, when you two said that, you got excited and I got confused because I didn't know what it meant. So just in case someone else isn't smarter than me, do you want to explain that real fast?
Yeah, so the Pythagorean triples is just like whole number ratios that give it, your side, your other side, and then your diagonal so that you get a whole number. So for example, for this dark one right here, 3, 4, 5. We know that 3 squared plus 4 squared. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, 5 squared is 25, that it all adds back to each other within there. Yeah. And you can Google Pythagorean triples. And also, yes, I saw something coming through. Do we have a key with the showing the math?
Well, I was answering that now.
Oh, yeah. Okay. Well, I was just going to say, if you go back to your Google Master, the keys for all of these, like the math, how to solve each of these, is listed here under your teacher links. So if I open this planetary air mass, just for example here, yeah, great. Thanks, Casey. And just to reassure everybody else that's on here, Brooke went through and added in, step by step. So you should be getting this, you should be getting this. Here's your ratio. All right. So, and you have that for each of the slides then on those that she included. So we're going to find our ratios, and we'll go ahead and plug these ratios in. So we go back to our form, and we're going to say, okay, the lowest calculated ratio of light to dark air mass volume of all the planets, what was the lowest ratio? Well, our lowest ratio was a 1. Our second lowest ratio was a 3. Our highest calculated ratio was a 5. So now it's decision time. The students need to make a decision. Which of these ratios is going to be the best so that our convection currents won't be ridiculous, that we won't have these high shear winds, we'll have research equipment blowing all over the place, we'll have this unsuitable environment. Planet 1, Planet 2, or Planet 3, what do we think? Well, let's say, you kind of have to think. This is kind of one of those, I love that it's a built-in critical thinking. Like, what do these ratios mean? That really anything higher than a 1-to-1.
You have 6 minutes. They haven't had.
Oh, haven't had a chance. Yeah. Okay. Well, anything higher than a 1-to-1, it's going to be, create this crazy shear winds from convection currents. So if you've already discussed convection currents, that might be a really good way to assess them. Like, are they really understanding what this is. And again, we'll get into convection currents
Yeah.
in a different session.
We'll talk
do
about it
this.
tomorrow.
Mhm.
Come on, join us. It'll be
Okay.
fun.
So let's say planet 3. Let's say I'm really impressed by this spot ratio of 5. It's 5's my lucky number. I'm going to go with 5. So I click on planet 3. I go here, and oh my god, game over. What? I look down and I see this crazy like tornado-ish. I don't even know. It looks nuts. This is just an awesome graphic here. And this, I see the ratio of air masses on this planet is too high. The shear winds from the convection currents will be too great. We'll tear apart our research equipment before data is collected.
In the original thing, that's not what I wrote. I wrote
Stephen wrote, your math sucks. And, basically you should go back to kindergarten, I think is what you.
I did.
Well, it was pretty, I don't know. It was pretty.
I said something, you killed, all your whole research team died and you've been fired.
Died. I felt like that was damaging, but you can definitely send Stephen a private message and get his feedback on what you should put. Let's say we chose, okay, I can go back because I don't know how to fix it. So Google form, you can't go back. Maybe it can be done. I feel like there's probably an add-on that would let you do this. I don't know. Planet 2, I win. You win. Planet 2 is the yay. It's.
I don't like the you win part, but.
Well, everything is a competition. Everything is a competition.
You and Brooke added you win. I just thought,
Yeah.
Yeah.
But this is, okay, the ratio of air masses on this planet is ideal. This is the planet with the 1-to-1 ratio that we're looking for. That's the best ratio that we want. If we go to,
I did. I took it.
There you go. That's a very beautiful picture.
I know.
If we go to planet 1, let's just see if I lose and I win, what could planet 1 possibly be? So that would be our ratio where we have the 3. Oh, you survived. Yeah, kind of. It's not ideal. The shear winds are still too high from the convection current, still going to be too great to support our research equipment. But we can see like a person here and like maybe their little pet android, I don't know. And conditions in this environment will be very harsh, but you could still survive, but you couldn't do your research and you can't go back to Earth. So it's just not an ideal situation. Like it's a real crappy situation actually. But anyways, there we go. And I submit it. And thank you. That's the end. Okay. Done a little. I like the jackpot one. I'm going to stop sharing my screen so I can see these comments because I feel like I've missed a lot. And we'll open it up for questions that you might have. Oh, thank you. Or give Stephen a chance to talk because I've monopolized.
No, you've done a wonderful job. Your energy is just exciting. Are there paper copy of things too? Yeah. We set it up to be entirely electronic for our purposes, but there's no reason you couldn't just print off like the word search and print off the different Jamboards.
Definitely.
You could definitely print those off and to hand those out in person if you're doing an in-person one. Mm-hmm. And did we ever do the lockbox video or presentations?
No, we didn't.
We've done at Hasty a couple times in other places. All right, we need to do that video so people understand more about lockboxes.
Okay.
Let's do it next week and post it.
Okay. So speaking of posting, we're going to continue posting, and especially if you have other questions about, hey, could you show us more about Google Forms, or could you show us more about this? If you have not already gone over to Purdue University Superheroes of Science on YouTube, that is sort of our repository for all of these. We're going to have copy, of course, all of the lessons ahead of time have all been uploaded there, but we will also put, like Stephen just said, our talk that we've given at several teacher conferences about lockboxes, just in general, just the mindset behind them and what you're thinking about going into it. Like we aren't just doing them for no reason. Like we have definite plans going into them that we want students to learn these things once they're done participating. So we can definitely go through, but we will put that on our channel. We have different playlists for teachers, for students. We have STEM content with the scientists, and
please subscribe.
Yeah, we appreciate subscribes. Thank you very much for the feedback. Oh, and as far as you don't even have to have locks. You don't have to have boxes. You could do a locked box
in person.
We've put papers before in drawers that don't even lock. We've just had like a hidden drawer that students have to find, or you can use envelopes. Oh, yay. So good. So I'm glad you're able to, maybe find pieces you can use. I'm telling you what, I would go back and do the reverse constellation thing where I give them the shapes and have them come up with the coordinates for that. And then use that as some kind of lock combination. I think that would be awesome. Especially I taught math and science. So I'm just thinking of, getting them
It'd be
doing both
doable.
of these things.
That'd be
Yeah.
doable.
Stephen brought it up. I wasn't going to say it.
She told me to change it. I might have forgot.
Oh, I'm so glad. Thank you, Michelle, for the theme. Glad you found it. And yeah, so thank you. Yeah, we really like, the kids love challenges. They love the competitions. I know Stephen doesn't like the competition side as much. Well, he says that. He's very competitive, actually.
That's why I don't like it, because then I'm obsessed with winning.
Well, that feeds some kids. Some kids need that.
I mean, it's like I don't always win.
Yes, the reverse coordinates, right.
No, quit encouraging her. Jeez.
Oh, and the hidden code in the crossword, that was you.
Yeah.
He has done this with every lockbox. He is like the crossword master.
Well, always have somebody glance at it and do it before you actually give it to the kids, just to make sure you didn't act. Because when you just start filling in words and letters, it makes words across and stuff. So it's just make sure you didn't accidentally get a cuss word just by random letters falling in place or something like that.
Yeah, that's actually easy to do. We found
I always try to proof mine and change a few letters here and there. We'll share if you want to do this one, and if you want to take the IU sucks out, because I was told it's inappropriate to put it in.
It is. Yeah.
But we'll share the sheet with you, right?
We will give that link to Bill that has the link.
Yeah, Bill, let's put that on the doc thing under presentation.
Yeah.
And so we'll make sure we share the sheet with you, so you can go in and change those.
Yeah. Just don't change it to produce sucks. No, none of that. We don't need any of this. We're trying to be fair to everyone.
And I'm throwing in there's the K-12 science at purdue.edu. That's a great email if you need to email and you forget who each of us are later. That goes to one big generic email, and then we can figure out where it goes. Yes, you can do Stephen sucks. That's fine.
We've done a lot of these with student groups that'll come in, and my favorite is when that we do this one, and the kids are like, Stephen loves ice cream. They just start out late. Where did you find that? And it totally derails it. It's not anything about anything. And I'm like, thanks.
I did. I was hungry when I wrote it. We'll share that one tomorrow, because that's a weather and climate walk.
Yeah.
We'll share that during the weather one.
Okay.
Let's show them that tomorrow. Okay. Yeah, during the weather one.
Okay.
That's a whole weather and climate clock box. That's a good one.
That is a good one.
That was the best one we've done.
We did that one. Actually, the weather and climate